Hey, welcome back to Mr. Pielsa with Pre-Calculus. This is Unit 2, Topic 1, Lesson 1. We're going to be talking about logarithmic functions and how the nature of logarithmics is basically to be the inverse. It is the inverse of an exponential function. So this is an exponential function like you learned back in like Algebra 1, Algebra 2. This is 2 to the power of x. 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. So the numbers go from 1 to 2 to 4 to 8 to 16 to 32. So the number just keeps multiplying by 2. It increases very quickly. And there's a horizontal asymptote. Now, logarithmic functions have a vertical asymptote. So they have a line in which they will never reach, which is vertical. This is log base 2 of x. So these are basically perfect inverses of each other. If you were to take this graph and flip it over the y equals x, then it would be this graph. That's what makes them inverses. The output of this, so if you input a number into this equation, let's say you put 1 in, so 2 to the first power is 2, then you take that 2 and you put it in over here. What power of 2 is 2? The answer would be 1, which was the exact same number I input into this one. So your answer here, inputted into this inverse, will always give you an output that was the same as what you input here. Okay, so that's just the nature of inverses as all inverses go. So whatever number you put into one function, the answer goes into the other one as the input, and then you'll get the same number that you started with. All right, so when we're looking at them more specifically, so you did hear me say the word what power, because that's pretty much what log is. So if exponential is the power, then logarithmic is what power? So it's just the opposite. So in this case, b represents the base, and y represents the solution. Well, in this case, the solution would be equal to the exponent. All right, so there is your logarithmic function. Now, there are some rules to logarithmic functions that you have to follow in order for it to be logarithmic, and that would be like things like the x must be a positive number, cannot be 0, nor can it be, because no number to any power is ever going to equal 0, so that's not a possible solution if you think of it in the inverse way. B has to be a base that happens to be greater than 0 as well, so B has to be greater than 0, and B cannot be 1. Okay, so now evaluating. You've heard me say what power multiple times. I'm going to continue doing that for a second, and I like to use a question mark. So I'm going to convert this from logarithmic to exponential. So this says what power of 2 is 8. So we're trying to find the answer, which is y. So I would say 2 to the y power. So if you look at the way that it's set up, this and this, so you would take the y, and that becomes the exponent. So the y here becomes the exponent. So that would be base 2 to the y power equals 8. Now you can just use your common logic. Well, 2 to the what power is 8? So that would be 2, 4, 8. That would be 3. So the answer is 3. Same logic for this one. So 5 to the what power, or I can put a y right there, equals 1/25. Now, since it's 1/25 and not 25, you know it's going to be a negative exponent, and 5 times 5 is 25. So this answer is -2. 5 to the negative second power is 1/25. All right, so for this question, it's really asking you 7 to the y power is 7. So this is your solution, because as you can see right here in logarithmic, x is the what it's of, and that becomes the answer in an exponential. 7 to the what power is 7? That would be 1 is the answer. So this question is really asking you 4 to the what power is 1, and that answer would be 0. 3 to the what power equals square root of 3. 3 to the what power equals square root of 3. Now you got to remember that square root of 3 is really 3 to the 1/2 power. So if this becomes 3 to the y equals 3 to the 1/2 power, well, you probably learned in Algebra 2 that once the bases are the same, then the exponents must also be the same. So that's how you solve it. So y equals 1/2. The answer is 1/2. Okay, so on the next one, remember that a logarithmic is an exponent. Okay, so I'm going to do basically the same thing I just did a second ago. Let me move myself here. Only we're going to state y. So I'm going to state y by converting it to an exponential. 2 to the power of 3 is 8. 2 times 2 is 4 times 2 is 8 because 2 to the third power is 8. All right, the next one is 1/2, and the reason why is because 3 to the 1/2 power is the square root of 3. 3 to the 1/2 power. This would be an answer of -2 because 5 to the -2nd is 1/25. 4 to the 0th power is 1. Anything to the 0th power is 1, a matter of fact. So anytime this number is 1, I don't care what the base is, the answer is going to be 0. 7 to the 1st power is 7. 4 to, oh, sorry, I was thinking it. 4 to the 1st power is 4. And this will be 2 to the 2, 4, 8, 16, 32, 5th power. 2 to the 5th power is 32. What power of 6 is 1? Remember I said that over here. That's going to be an answer of zeros. Anything to the 0th power is 1. 3, 9, 27, 81. That answer is 4 because 3 to the 4th power is 81. And remember this is, okay, all right, so this is really 5 squared. So this is really 5 to the 2/3. So the answer here is 2/3 because 5 to the 2/3 power is the cubic root of 25. Now, this was a little bit tricky. I changed the 25 to 5 squared, and now that I got the same base as the base in the log. All right, so now we are dealing with common logs. So logarithms with a base 10 are called common logs. So basically, you can drop the script of 10, and that's technically what it would be. So in this example, so you see, you have logarithmic of 100. So that's the same thing as log base 10 of 100. Because our number system is in base 10, so we consider using base 10 as just commonly writing logs. So in this case, 10 to the 10 power is 100. So that's the reason why. 10 to the 10 power is 100 because what power of 10 is 100 and it would be 10. So same thing for this one. So this will be the same thing as log base 10 of 10 to the 1/5 power. So the answer, what power of 10 is 10 to the 1/5 power? And that would be 1/5. So the answer is 1/5. And the reason why is because of what I technically just wrote. 10 to the 1/5 equals 10 to the 1/5. Log of this, so this answer would be 10, 100, 1,000, so that'd be -3. The reason why is because 10 to the -3 is 1,000th. All right, log of 10 to the 3rd, so that answer is 3. What power of 10 is 10 to the 3rd? Well, it already is in the power of 10, so it would be 3. What power of 10 is 1,000? 10,000, sorry. That would be 10, 100, 1,000, 10,000, so that would be 4. What power of 10 is 10 to the -4th? And that would be -4. All right, moving forward, I'm not quite sure if I'm recording my thing. My screen went out, I lost power, and I have a feeling that I'm no longer getting shown. Oh well, special cases. No base means common log, as we just said a second ago, so that's like power, that's like base of 10. So that answer is 1. That would be 2. 10 to the 1,000th would be -3. 1 1, 2, 3, 4. Okay, so that'd be 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. Looks like that's -5. ln means natural log. All right, so we also have a very commonly used logarithmic function where you use e as the base. And if you don't remember from Algebra 2, e is basically that number. It's an irrational number, like 2.718. And it represents keep in mind it's a irrational number, it goes on forever. It represents the absolute most amount of money that you could continuously compound money. So if you compound it, not every month, not every day, not every minute, but literally not even every second, but like continuously, like every single absolute moment, it's the absolute most amount of money that you can get if you compounded it continuously forever. So this is really log base e of 1. So what power of e is 1? Well, the same with any other number, it's 0. Anything to the 0th power is 1. So this is e to the what power? So this is technically log base e of e to the -3rd. What power of e is e to the -3rd? That would be -3. This is basically log base e of e to the 2nd power. What power of e is e to the 2nd power? And that would be 2. The answer is 2. And this one would be e log base e of 12, which means what power of e is 12? So in this case, looks like you're going to have an irrational here. So e to the what power is 12. Once again, irrational. So that's not going to necessarily be possible to give you an actual answer in this case. So it is not defined. All right, logarithms are the inverses of exponentials. Oh, I'm running low on time. We can evaluate simple logarithmic expressions using understanding of exponentials. As I just said, logarithms are base 10 is called common logs, and if it's an e, then it's natural log. All right, thanks again for watching. Have a great day, and please continue to watch the videos and subscribe if you haven't done so already. Have a great day.